So in the context of the index laws, when you have, for instance, like 1 power, which is of a product of two terms that can be distributed, whether it's a fraction or an integer is irrelevant. You handle it the exact same way. Same with distributing it through divisions. As for how you actually get those fractions, those are just root terms. So let's see, do we have any? Here we go, yeah. So how to convert from one to the other, typically you'll get stuff like this, which is there'll be some sort of type of root, typically a square root, but sometimes they'll do third root, fourth root, and that'll be the denominator of the index. And then whatever the base of the thing has a power of, whether it's in the bracket of the root or on the outside of the root, it's the exact same thing. The order there is irrelevant. That will always go in the numerator of the indices. And so that's the main thing you'll have to keep track of, which is how do I go back from one to the other. Once you have that, you treat things literally the exact same way you've always done with the index law stuff. That's probably it for like a high level looking at it. Was there anything to clarify about that so far?
No, I got that.
Cool. Okay. So as far as getting some practice in, let's see, it'll be in the exponential side of things, I hope. Might be in Unit 1 and 2 actually.
Yeah, I've just I started exponential graphs like a school.
You started exponential, yeah, okay, graphs.
Like we just started it.
Cool, okay. You're using this book, Unit 1 and 2, Cambridge?
No, I'm in year 10, so I use the year 10 book.
Oh, okay, right, because you're not accelerating it, you're learning it ahead of time, but not accelerating it.
Yeah, I mean year 10. My school doesn't provide methods in year 10.
Yeah, okay, got it. Okay, cool. Let's see if I can find it in here then instead, because it seems like this one's going straight to like the graphs and stuff. So we're going to do more of like the index law manipulation. That'll be, oh, where is it? (13B), rational indices. It's a relatively short chapter there, although they do get into the complexity quite fast. Are you looking to start out around here, or do you want to sort of work your way up to it a bit?
Can you work our way up to it?
Yeah, certainly. So these are a bit on the easier side. There's not going to be any of the fractions to worry about, but this will at least get you back in the swing of the basics of the index law so that you can then apply them to those fractions. So here's the whole page. Whereabouts are you comfortable starting?
Any. I think, yeah, I think I know these.
All right, cool. Maybe do like one of, we'll call it 6B maybe. If you could smash that out, then that'll at least get you in the swing of things. And even if I do have to work through the first one with you with the fractional indexes, that's fine as well.
Right.
Okay, so that'll be this one here. See how you go.
Is it 125 a to the power 12 or c to the power 3?
Something went a little bit off. You want to have 125, yeah. The A should have fully cancelled out. you should have a b to the power of 6 on top and a c to the power of 9 on bottom. Let's see, what's a good way of doing this? Do you want to like double check your answer, or do you want me to pull up a mock solution?
Okay, wait one second.
Yep.
I think I know what I did wrong. Okay, just like show me the solution.
Yeah, certainly. So here's one I prepared earlier. This tends to be one of the questions, or one of the types of questions students struggle with the most. So we're doing 13A, 6B. Cool. So this is the overall approach that I'll do. I typically start by resolving any like what I refer to as cascaded powers. So, you know, when you've got like this big set of brackets and a power, big set of brackets, a power, I'll distribute those through as the first step. Is that more or less how you start yours out as well?
Yeah.
Yeah, cool. Okay, that's good. So that's just the product. So it's going to go through and multiply each of those indices. From there, division tends to be a bit of a pain. So what I'll typically do is just flip it to a multiplication, because then, for whatever reason, that seems easiest to look at. Then I'll go numerators and denominators into each other, rather than trying to cross out already. Part of the reason why is because I'm seeing like some of these denominators can condense into each other.
Okay, yeah, I see what I got wrong.
Yeah, okay.
It was flipping the thing. Yeah, I flipped it. But since it was a minus, I kept A6 and C3 in the top and B3 in the
Yeah, okay, so it wasn't quite a flip. If you had done that, you would have had to keep that as a division symbol and left this as a fraction. Yeah, so you have A6, C3 up here, and then B3 down there, but that would stay division in that case.
Yeah,
okay. But yeah, that's all. So it was only like a minor thing there. But cool, okay. So that's the kind of level of complexity that these, and probably also these will probably be easier actually. Do you want to practice any more of the stuff from this?
No, that's fine.
That's fine. Okay. Now, where we would probably start would be somewhere like 2A here. Do you know what you would do to start this off?
So I would make it times 1 over square root of AB to the power 3. So I make it into a fraction.
Yeah, convert this to the fraction version. Yeah, that's right. So just to be clear, the way you would convert that, since it's the third root, it would be basically replacing the root with a set of brackets, and that bracket will be raised to the power of 3. So if we have the handwritten bit here, you now have a squared b all to the power of a third. That's just pure simple. No actual arithmetic has happened there. We're just rewriting it in a different way. Very similar thing going on the other side. What do you think I'm going to end up with over there?
Wait, one sec. I can't get the screen up. Other one.
Okay. So the screen share itself will just be like your top tab. You can click between the meeting room and the screen share.
Yeah, no, I got it. It's just that.
Yeah.
It's there's 3 screens. That's why.
Yeah. Right click on the one that you want to look at, and you can pin it. That will always have it as the active window for the meeting room. So right click and pin is underneath chat.
Yeah, I got it.
Yeah, easy. But okay, so far we've just converted that first root into a fractional indices equivalent. What's the second one going to now look like?
The second one, in brackets, a b to the power 3.
Yep.
1/3. Yeah, 1/3.
Not
No, 1/2 squared.
Yeah,
1/2.
That's better. Cool. All right, now from here you just treat it exactly the same as your regular index laws. Do you want to take it from here yourself, or do you want me to keep doing the same way like this?
Sure, I can do it myself.
Smash it. Let's go. It came off from you. Did you say something? I might have cut out.
No.
Oh, okay.
Wait, how do you do this again? I kind of forgot.
Sure. Okay. You still where we left off?
Yeah.
Okay, cool. So let's pretend these aren't fractions and these are just the actual numbers themselves, 3 and 2. What do you do under those circumstances?
You just multiply it.
Okay.
Say like 8, 6, b3.
Yep. And over the other side?
8 squared b6.
That's it. Cool. Same thing here. So you're just going to multiply everything in every index in those brackets by a third.
Oh, yeah, right. So a to the power 203.
Yep.
And b to the power 103.
Yep.
And then just times that. Times, oh yeah, divide a to the power half.
Yep.
And b to the power 3/2.
Perfect. There you go.
And then
yeah.
you flip it off times again.
Sure.
You do. Do you write the same thing again? Or
Yeah, it's the same thing. I just sort of, was being a bit lazy with this writing.
or like you make it like a1, or is it wait, I think you make it somehow to like simplify, right?
Yes, we still got to simplify from here. Everything is going to condense down into 1a and 1b term. Again, I'll use the same sort of idea as before. Let's say I just had A2 and then A1 over here, and I won't write the rest of it. How do you simplify those A terms?
A2 and A1.
Yeah, so let's say like I'm basically only writing a part of this, but instead of using fractions, using the numbers. Let's say you had this, right, which is a squared on 1 times 1 on a, basically.
A squared over A.
Yeah, a
And
squared
then,
over.
so just A.
Yeah, so more importantly would be to specify it's a subtraction between these, right? 2 minus 1 gets you back to 1. So in this case, it's 2/3 minus a half, a third minus 3 on 2. The index law states that when you have division, you're subtracting the indexes.
Okay, yeah. So it's 1/6. A 1/6.
A 1/6, yep.
And minus 7/6.
And minus 7/6 for B. Yeah, correct. Perfect. So yeah, the index laws never change. That's why in my notes here, you'll see, yep, you can distribute the indexes, and they're actually even labeled the same law simply because whether it's a fraction or an integer, same thing, even if we have a look at the addition and subtraction stuff, right? So when they're multiplied, they always add, whether they're fractions or otherwise. When they're dividing, they're always subtracting whether they are fractions or otherwise. But okay, very similar level of complexity over in part B. Give that a shot.
Three B, right?
Uh,
Wait, 3B or
2B.
R2? Could you scroll up? I can't see the thing.
Can't see that.
Wait, then I can see it.
Okay.
Is it B 9/2 over AR divided 6?
Yeah, B9/2, A minus 6. Yes. Perfect. Very good. Okay. Part C, slightly different. So now we're starting to get those numbers involved, which uses a different tactic, although shouldn't be any different to what you did in the previous chapter, or at least when you did it in school. Want to try this one as well, or do you need help on how to start?
I got it.
Easy. There'll be a bit of mucking around on this one, but should be alright.
You make it the same base, right?
Yeah, correct. You want to get it down to as small, so prime bases, as small bases as you can make them. The tactic is referred to as prime decomposition. Fancy way of just saying make it as small as possible. I found it's actually kind of cool to use in non-index law scenarios as well. There's been a few exam questions in Tech 3 where you have to simplify quite large numbers, and techniques like this can be quite powerful for them.
Techniques like which?
Like what you're going to be doing to solve this one, breaking down, like for instance, the 45 into 15 by 3, and then 15 gets broken down into its factors. Breaking things down like that is a really good way of simplifying things because...
Basically like a factor tree, right?
Yeah.
That's like what school teachers teach us. It's like factor tree and like it's like a longer method.
Like a longer method. I'm not exactly familiar with what you mean by a factor tree. I get the idea of it, which is just what's all the factors and then go down to the bottom with all the smallest ones. I'm not sure exactly what that will look like on your paper, but yeah, you're basically just breaking it down into the smallest possible factors, and then because you've done that, you can sort of consolidate things a lot easier.
What's the smallest factor for this? Would it be 3?
Well, there'll be 2 smallest factors here. 3 is one of them.
So 3 and 5.
3 and 5. Yeah, that's it. Everything in this scenario can be broken down into 3s and 5s. It's kind of like finding your A, B's, and C's. In your letter examples, they're kind of just there for you, but in the number examples, you kind of have to get them there.
Oh.
In fact, yeah, it's kind of exactly the same. If you had like AB or like 3AB, for instance, you'd want to split that up into A and B and 3. But this is kind of the reverse, which is you already know the number, so you've got to break it back down.
So would the 5 be on the top or the bottom after simplifying it?
It completely depends on how you've expressed the index. So if you want a positive index, it'll be on the bottom. If you leave it as negative, it could go on the top.
So what's the answer? Is it just 5 to the power of 9 over 30 over 3 to the power of 9 over 8?
It could be, but if it is, it's not fully simplified. Let me grab up the solution doc. Okay, so this was part C. So I kind of mentioned before, there's going to be a bit of mucking around. I've chosen to express my final answer like this, using negative indexes and just having it all in one line. You do need to get it down to at least the positive or negative of those and express that. However, here's the way I've gone through it. Would you like me to walk through this, or do you want to try and fix up your answer?
Can you walk through it?
Yeah, certainly. So again, first thing you want to probably do is break down the factors as well as you can. I've kind of gone through in a bit more detail than you otherwise would. Like for instance, 45 into 15 by 3 and then into 5 by 3 by 3. If you can already imagine in your head that 15 is going to split, you don't have to have another line like this. But okay, so splitting the 45 into 15 by 3. In fact, sorry, I've done that left to right. The 9 goes into 3 squared, the 15 goes into 3 by 5. Then from there, what's the next step? Is this just a repeat of that? I think I might need to refactor this a little bit. Anyway, splitting the 15 into 5 by 3 by 3. That's the only thing there. And then from there, condensing the 3's into 3 squared. So as of this stage here, everything is in a prime factor. You got 3s and 5s. Nothing else is left, and everything is about as condensed as it could be prior to the distribution of those powers. Cool so far?
Yeah.
Okay, from there, doing exactly as we would have done before, which is distribute those powers through. So a third is going to multiply each of those indexes to give us that. 3/4 is going to multiply into that there to give us 6/4, which obviously simplifies. We can do that maybe a bit later. 3/2 goes into that one and that one, which is, well, exactly as you see there. Then from there, just combining the like terms. So the only things combined there would be these 3s, which is going to condense down into that. And then from there, just looking from numerator to denominator, up and down. So this is just your basic subtraction. The 5 indexes will subtract, the 3 indexes will subtract. And I've just chosen to leave that in negative indexes as opposed to 1/5 power 7/6 times 3^7/3. Seems a bit silly to use 2 lines when you can just use 1.
Oh, I got it. So yeah, I think all my I know all the concepts and stuff and topics, but I think my fundamentals are kind of like rough.
Yeah, actually executing on it is going to be the main issue. And so I think having a good idea of the order in which you want to do things can be kind of nice, because sure, you can look at this this massive list of index law stuff and be like, yep, cool, okay, I know I can do that, I know I have this tool, I know I have this tool, sure. What order am I doing things in? That's why I kind of go into a bit more detail with the solutions I've written out to say, hey, look, this is the order in which I'm doing things, and I pretty much will do that on a consistent basis every single time. Like, you could try to distribute this power of a third through to each of these already, but you probably wouldn't want to do that. So my recommendation for these kinds of questions, when you do have numbers as the bases, is start by breaking down those bases. Did you get at least that far in your first go, getting the right bases down?
Yeah.
Okay, well, that's good. So starting with the bases, then from there, we pretty much just revert back to the exact same stuff we do in 13A, which is starting with the cascaded powers. And then if you do have multiple terms, you can kill any divisions you see. In this case, we didn't really have that, even though it kind of looks like it. I'm just kind of going left to right. We didn't really have that, so we can ignore any flips. From there, we simplify numerator and denominator individually, which is exactly what I've done over here, simplifying, well, only denominator needed, simplifying there. And then from there, once those are already as simple as possible, then you will go from up and down, simplifying that way. You don't have to copy this exactly. I would do at least these two in the right order that I've presented. And then from there on, you can do pretty much whatever you want, whatever seems nicest to you. This is just how I do it in a systematic way. Only lesson I'm trying to impart.
That's the part I didn't understand what to do, like for the fractions.
This part down here is where it gets
Yeah.
tough. Yeah, okay. Just treat it as, like, pretty much put blinders on for each individual part. So you just go, look, I'm going to pretend this doesn't exist. What would I do to simplify this? Cool, that's that. Now I'm going to pretend this doesn't exist. What am I going to do to simplify that? So that's pretty much why I'll do it that way, numerators first and denominators, or whatever order you want to do that in, because then you're just treating it like every other thing you've done before. It's just straight line, cool, straight line, cool, done. It's only once you get to here where it might get a bit trickier. Some people like looking at the negative indexes, so if it's just the pure visual of the fraction that's a bit annoying, you can split this off as a multiplication of 1/. So kind of like what we did here. If that sort of visual is more appealing to you, then you can absolutely just split off this denominator, and then now it looks like multiplication, so you can do your multiplication rule stuff. What do you think? There's a bit of flexibility around here, how you handle that. What do you think is more appropriate? Keeping it as fraction and then do subtraction, or splitting it off as negative indexes?
I think keeping as a fraction and then doing that. And then just like minusing it.
Yeah, okay, cool. So whatever conclusion you come to, whether it's that or whether you change something else, just once you find something that's working well enough, just sort of drill that as many times as it takes for it to become second nature. One of the themes I will sort of touch on throughout our time, if you want to continue with the classes, that is there's going to be a lot of ways to solve many questions. So typically you'll be best off just trying to find at least one way that works really well for you. And once you've grinded that one out perfectly, then you can do the other stuff. Like for instance, quadratics, right? If all you know how to do is turning point form and completing the square and you can't really do quadratic formula, that's fine. Smash that out, be perfect at that, and then look at quadratic formula. Better to be getting be perfect and getting the mark for one thing rather than being sort of average at everything, because unfortunately marking is very binary. You either got it or you didn't. So if you're just sort of average at everything, you're rolling the dice on each question versus being perfect at some stuff and can be like, yep, I can lock in that mark. Anyway, that's just a bit of a philosophy for how you can approach more so like exam style questions and SAC stuff. But yeah, to recap, that's the procedure, which is if you have those bases to simplify, then by all means go for that at the start. Then distributing the cascaded powers, that seems like stuff you already do. And we then just come to the conclusion that we should then simplify numerator denominator individually and then do subtraction from there. Cool?
Yeah.
Okay. This one looks like it'll be a lot, maybe not too much a lot easier, but a bit easier for part D here. Let's see if we can apply that.
B, right? Or D?
D here.
D. All right. Is it 2 to the power of minus 1/4?
2 to the power of minus a quarter is kind of close. Not quite. Minus a quarter. Where could that have come from? There was a minus a quarter in there at some point, but it does get condensed down into what you want to have is 2 to the power of minus 2, which then would equal a quarter, which is why I'm saying it was kind of close.
2 to the power minus 2. I did so I first from the start I first I just made negative powers into fractions.
Negative powers into fractions. Hang on.
Yeah, like 1/4 4 to the power 1 over 4 and times 1 over 16 to the power 3 or 4.
Oh, sure. Yeah, okay.
Yeah, that's what I did first. And then I simplified it, so I got 2 to the power of 3 over 2 over 2 to the power wait one sec. I got 2 to the power 6 over 24, I think.
6 over 24. That's
Wait, one sec. Let me type in the question again.
Say again.
I'll try it again.
One more time.
I'll
You're still
try
on
to.
record. Oh, you'll try doing it again. Yeah. Maybe just, I guess, as a tip, I probably wouldn't recommend splitting them into fractions like that. Might be best to
Just do the power straight away. Alright.
Might be best to do the bases actually straight away. So split the 4 into base 2, split the 16 into base 2 as well. You can then split it into fractions after that, but having a smaller base, whether it be as the numerator denominator, is going to be easier to work with.
You just add the powers up, right?
Yeah, it's all in one line, so addition of powers, yeah, or multiplication is always adding.
Yeah, I just realized how easy it was.
Yeah, it's not too bad, this one. It's probably a bit easier than the other one, but
Yeah, I just don't know how to approach the questions every time. I approach it like a whole different way, and then it gets so complicated.
yeah, that's kind of what I'm saying, which is like it's good to have like one standard way where you go about them the same way pretty much every time. With these kinds of things, you kind of have, just looking at like this page, there's two main approaches for these kinds of questions. So for instance, 2A, 2B, 2E, 2F have the exact same method of approaching. C and D, because you now have to do the prime decomposition thing, the base has got to simplify. That's like another layer on top of the thing you would do for the rest of 2. 3 has its own approach, which we'll look at once you're ready for that.
Yeah. What's the answer for it? Was it 8 to the power of minus 5 over 4?
Let's say again.
8 to the power of minus 5 over 4.
Maybe, but the smallest base should not be 8.
I times it. I times all 2 together.
Oh, okay, that's what you meant by that. Tough. So when you do index law stuff, that'd be kind of like multiplying the A's together. You don't really want to do that. You want to multiply. Multiplication means adding the indexes. So instead of grabbing all the 2's and smacking them into each other, it's...
Oh, I see. You didn't times the I times the 2's, the base 2's together, and like it says 8 to the power of minus 4 over 2.
Oh, okay. So you've doubled up. You've double dipped then. So you've done the bases and the... Yeah. So that'll be like saying a squared times a squared is equal to 2a4, which is a little bit off, right? The bases will always stay the same.
Oh, okay.
Yeah. So basically, pretty much any index law, you never touch the like any of the actual index law stuff. You never touch the base. It'll always stay the same. It's only ever when you're doing... This is kind of like an offshoot from index laws. I guess it's factorizing. I guess at its base, it's factorizing. It's a little bit removed from index laws. You can actually touch bases when you're doing a bit of factorizing. But yeah, when you're actually doing anything with the indices, you never touch the bases. But all good. Again, we're here to practice, right? If by the end of it all I can give you is just a generic approach that you use from start to finish, then that'll be considered a win, because I have a feeling like if you saw this in the textbook, you'd probably figure out your mistake pretty quickly.
Yeah.
Yeah, okay. So if we're at that stage, then that'll be a good thing for you, where you can spot what's actually going wrong. And I see the main purpose of these as either troubleshooting the things that you can't immediately spot, or teaching you new things to work on. But cool, okay, so that's that. This is no actual fractional indices anyway. You can try it if you wanted to still practice more of the index law stuff, but seems like part F is more so what you're looking for. What do you think?
So what should I do?
I mean, E is going back to no fractional indices. So if you want to practice just more of the basics of simplification stuff, then that's there for you. Otherwise, we can continue on with the root stuff. Either E or F.
Okay, we can do the roots.
Yeah, okay. Give F a shot here. Actually, before you do, maybe can you speak high level, like what overall steps you're going to try and follow as a procedure?
For F.
Yeah, for F. Like, what's the first thing you're imagining doing here?
Let me see. Convert the roots into fractions,
Perfect.
and
Great
then
first step.
add, and then like times the fraction power with the one outside the bracket,
Perfect second step. Yep.
and then you simplify it after you get that.
Yeah.
So
Yeah, bit hard to see what's going to happen after all that, but yes, those are two perfect starting points for that. Nice.
sounds like a to the power of 4 over. Is the numerator a to the power of 4?
Should all condense down into one thing, so it should just be a to the power of something. It'll be a fraction in that power, though. I think, yeah, what could you have done?
Yeah, how when you know how it's in a bracket a squared over 5 to the power of 3 over 2.
A squared over 5. When you, I'll pull up my version of it just to make sure. When you did that, this division of 5, did you write it like that?
A squared over.
Or did you have like an actual division of 5 on the whole thing? Because this 5 should only go on
Okay, yeah, I got what I see. Yeah, I see what I got wrong.
Okay. Yeah. So the numbers of the roots only ever basically just all index related stuff.
And then you,
So yeah, maybe like probably about a half step in between that would be. Oh, actually, I did it here. Oh no, I didn't. Sorry. Let me.
okay, yeah, I got it.
Yeah, you've got it. Okay. Maybe
You
just.
just now, I didn't do, I haven't done what you call indices for so long,
Yeah.
so I've like forgotten how to do it.
Yeah, no, that's fine. I'm just trying to imagine if there's maybe an easier way for you to present your own working so you don't make. Because was the mistake to put this 5 as a full division on this thing?
Yeah,
Yeah.
I just forgot how to like simplify, like make turn root into like a fraction of fractional root.
Yeah, okay. I mean, it might just be as simple as yeah, like to fix your errors, it might just be a matter of like just print off a copy of the index laws, have that next to you, and be like, okay, cool. I want to do this thing. I'm not going to do it until I see exactly what it looks like on the sheet and copy it word for word. It might require a bit of that just to get you back into
Yeah,
the swing of things. You don't have to do it all the time, obviously, just enough to where you're like, okay, cool. I think this is what I can do. That's what number 3 says I can do. Cool, I'll do that. That, might be a helpful thing. It shouldn't be hard to grab a print of that. In fact, I think even the Cambridge book itself has kinda. What's it missing? Does it show how to convert? Kinda. It does that bit, but it doesn't show you how to handle when there's another power in there. Does Unit 3.4 do it? Either way, I mean, you could Google any of these sheets, right?
yeah.
Do you want to take time to copy some of these down, or do you want to just Google it later?
I'll get them later.
Yeah, cool. Okay, so that's the end of the practice on those. I could probably scroll down to the chapter review and try to do more of those, or we could have a look at one that's going to be approached slightly differently. What do you think?
Oh, how did you do this?
Hey,
How do you do question 3?
how to do these? Okay, cool. Before I give away exactly what to do, is there any similarities you can see between all of these questions?
2x minus 1 and 2x minus 1.
Yeah, exactly, right. You can see they both share a common thing inside the bracket or inside the root, either way. One thing I'll do, which is really...
Do you just wait? I think do you just combine like turn the square root into a fraction and then just like to simplify normally
Perfect, exactly right, yeah.
as like the whole like as a whole like expression in the bracket?
Yeah, so you basically treat the thing in the bracket as the base, absolutely.
Yeah, and then you just like simplify it.
Yeah.
So the first one would be like the first one would be just 1.
Not 1. Although maybe you're talking about the power. The power of the first bracket would be 1.
Yeah.
Then the second one would convert to what?
Would it be 2 over 2x minus 1 or 2x minus 1 over 2?
Neither. The half will be in the power of the whole thing. So if you have a look at the handwritten note bit, I've got the copy written down there.
Oh, okay, yeah.
So the roots stuff will only ever go into powers. Then from there, do you know how that simplifies?
Times 2x minus 1. You just add the power of half and the power of 1.
Absolutely.
Like you add it. So 2x minus 1 to the power 3 over 2.
Perfect. Crushed it. Yeah. Some students will prefer to do a little half step where they'll say, okay, 2x minus 1, 2x minus 1, let them be u, or some other letter. That was almost an a, so let me just do an a anyway. A to the power of half, and then all of a sudden it looks even easier because you just do a little dummy substitution. That's only if it's like purely visual. You don't have to do that. Yeah, that's the exact strategy used for literally that entire question 3. So there's once you've done it, you've done it. Cool. Okay, still got a bit of time left. So let's see if I can spot any of these in the chapter review. Chapter 13. None of those were fractions. And the rest is extended response. Cool. How about this one? This got anything fun in it? Not really. It's pretty easy there. You know what? Maybe I could even show you one more thing. Oh, no, actually I can't, because this will be not really index law stuff. This is like solving full exponentials. That's a bit different. How much into index law stuff have you done already?
That's cool.
Yeah.
One set.
Like for instance, if I show you example 8 over here, 4 to the power of x equal to 256, is it clear enough how you solve that?
Yeah. Like no, we're doing exponential equations.
Yes,
Like
this would be
exponential graphs and stuff.
okay. So you're more on the graphing side of things, not on when it actually
Yeah, we're
equals.
doing like more of the graphing stuff
Yeah.
right now.
Okay. So yeah, the thing I was going to show you would need a bit of that to explain. So maybe we'll save that for a later time. Yeah, it doesn't look like there's too many more of the fractional index stuff, which is good news for you, honestly, because it means it doesn't show up too much. But there's plenty of ways to practice it. Maybe the jacaranda stuff might have some. We're gonna have to.
At school, the last thing we did was like we're doing right now on exponential equations, but like the last thing we did was fractional equation yeah, fractional indices.
Yeah.
And before that was scientific notation. So
Oh, you haven't done scientific notation. Sure. Yeah. Okay. I'm just gonna see if I can pull up the jacaranda book because that would hope still has stuff as well to look at. Although it's a bit harder to use because there's no chapter thing that I can easily click. Let's see, where do they have it? Exponential indices 587. Yeah, there you go. There's some stuff. Cool. Are they going to give me any actual questions or? Yep, certainly are. Where's a good place to start? I guess D over here would do. 3D.
so you just simplify first and then get the -1 as a numerator, so it becomes like a so it doesn't become fraction. And then you simplify again.
Say again?
So you simplify all the brackets, right? With the bars.
Yeah, that's good. Yep.
And then the same thing with the bottom half, and then the negative 5 after simplifying it, you flip it.
Yeah,
So
yeah,
it
that's
goes
a
to
good
the top.
idea.
And then you simplify the whole thing after that.
Yeah, that's probably another thing we didn't really look at, which is what happens if you have negatives in there. Yeah, flipping the negatives back into their positive spots is a good step in there as well. Yeah, good idea.
You know how it's 2x, it's after simplifying the 2x minus 1, yeah? It becomes 32x minus 5, right?
Close. Oh, hang on. Did you say 32? Yeah.
Yeah,
Yeah.
32x
Sorry.
minus
Yeah.
1.
Yeah. Yeah.
And then when you flip it, do you only flip the x, right? Not the 32.
Correct. Yeah. So
Oh, okay.
indices only ever apply to the thing directly attached to it. Yeah.
So is it x to the power 14 and y to the power 7 over 2?
Perfect. Yeah. That's exactly right. Crushed it. Yeah. That's pretty much it. We've got, yeah, here's one of those ones where you got to get down to simpler space. Yeah, we should be able to do that in 3 minutes. If we go a bit over, that's fine as well. See if you can get E done. 3E.
Does 243 have a base of 3?
It does, yeah. You can pretty much infer from the rest of them.
Wait, so like,
Yeah, if you want to speed things along a bit, you can use a bit of calculator if you want to just quickly figure out how to convert that down. In the real thing, you would just do like your basic division table.
so 5. 5.
Yeah, I think that's right. 3 to the 5. Yeah. 3 is a small enough number that you can sort of even just count the powers up relatively
Yeah.
quickly.
So is it 3 3 to the power 7 over 2?
Mashed it. Yeah, really good. 3 to the 7 over 2. Nice. And that's probably one of the... Yeah, it's about the same level of difficulty as the other... Where was it? The other one we had a look at. So that's good. We can see you're progressing with them all. How do you think? You reckon you can do a lot of these yourself at this point? and or at least even with maybe a bit of solutions to look at.
Yeah.
Easy. What I could do, where did I send you the stuff last time? Did I give you the... I sent you textbooks before. Do you remember where oh no, it was on the school thing, yeah. I could send you the Jacaranda ones as well if you want to practice more of those. So not only will you have the Cambridge, you'll have the Jacaranda, and you'll have the textbook you're actually using. So that should be plenty of index law stuff to practice on. What do you think?
Yeah.
Easy. Cool.
I have a question.
Yeah.
The classes, right?
Yep.
Is it possible, like, you know how the class that you're doing right now is like methods, right?
Yep.
With like approach.
Say again.
You know how the class that you're doing right now with approach, right? Is like
Oh,
for
yeah.
methods.
Yeah.
One is it methods 1 and 2, right?
So nominally it's methods 1, 2 for the class 1 and methods 3, 4 for class 2.
Yeah. So could you do I think that's a bit too hard for me.
Okay.
Like I've like learned all the topics here, and like if I like just go straight into 3 and 4,
Well,
I wouldn't like really understand.
did you struggle with the polynomial stuff?
Yeah, a bit.
You did. Okay. I think you did the polynomial division quite quickly when I asked you the last time.
Yeah. Besides that, though, I think the other ones I didn't really understand it.
Okay. I mean, I won't be the judge of what you find hard or not, but it sounds like you're most of the way there if you're doing the polynomial division stuff already. But okay, so you're finding it a bit difficult for now.
Yeah, is it possible to like just do like year 10, like with me? Since like Upright is doing 3 and 4.
Do just year 10 with you in these.
Yeah.
So the problem with these is they're set curriculum, right? It's not like I'm doing specific for him, specific for you. The only time I'm ever doing specific for someone is if that's the only person in the class, right? It is a group class thing, which is why, because it was just us, I could do something specific for you. This group class is going to fill up a lot more over time. I'm not going to be able to do that personally. If you're looking to have that sort of thing, that will be more of a private tutoring program that we talked about earlier. Okay.
Yeah.
So basically,
that's understandable.
the next thing, the main thing I guess you would get out of it would be the class 1, which is unit 1, 2, closest to what you're doing. And these are nominally catch-up classes for 1 and 2 and 3 and 4. So I'll go through the lecture bit and then, we can take it from there. So you still got at least 2 spots there where you've got stuff that you're comfortable with learning, if you're willing to do it, I suppose.
Yeah, all right.
What are your thoughts? Do you want to continue?
I'll-
or do you want to...
I'll let you know by tomorrow.
By tomorrow? Sure, yeah. I mean, it's up to you, right? If you change your mind later on, this is always still going to be here. It's not going to...
Yeah, I'll probably come back in like methods where I start like where I'm like fully done with year 10. I know all my fundamentals and stuff. Then that's like when I can like just like start going into methods.
Yeah, if you
And
want.
like,
It's up to you. You know,
and I wouldn't like get confused between like year 10 and methods. Because like I know like the same, like the topics are like the same all across.
They are, yeah.
But like if I don't know like my fundamentals like fully, then I wouldn't like really know how to do like the harder questions, methods.
If you don't know your fundamentals, good. I mean, that'll be true for all of math.
Yeah.
But,
That's what.
Yeah, this is meant to accelerate your progress. So it is meant to push you a little bit to study more so you can keep up with it. It's meant to give you all the resources to support there. So maybe if you're looking for, like, even if you do want to like quit the classes or whatever, there's the resource pack that we have in the school, right? Which is you can do them at your own self-pace, right? So maybe you don't completely take a full year off. Maybe you do, all right, I got the pack, I can look at these lessons on my own at literally whatever pace you want. You won't have to feel like you're trying to get with a class or whatever. That's another thing to consider. So you're not taking like a full break off accelerating.
Okay, yeah.
But yeah, like totally up to you. Again, as I said, this isn't going anywhere. It's more so how fast you want to progress through your math, I suppose. Because I mean, Upraj did a very similar thing, right? So you've got at least one proof point where it can be done, but it's up to you at the end of the day, right? I don't want to put undue stress on a VC, on what will eventually be a VC a year.
Yeah.
Anyway, I'll leave you to think on it. I'm not going to ask you to make a conclusion right now. I'll leave you to it.
Thank you.
No worries. Take care.